Okay, so the first set of directions for questions 1 through 3 are about finding all the zeros. So all the zeros include real zeros, which would show up as x-intercepts if we graphed them, and imaginary zeros that don't show on graphs. Okay, and question number 1 is only a quadratic, so this is kind of a reminder since we just did this a couple weeks ago. If I want to solve a quadratic, I'm trying to figure out where this equals 0. And the two techniques that I typically really lean on is factoring, because most things factor, but this guy doesn't factor, and quadratic formula, because quadratic formula is the only one that always works. So I suspect we're going to need that a few times today, so let's make sure that we still remember that formula. So one step to jot down the formula, one step to plug in the opposite of b, and then plug in b again, and plug in a, plug in c, and plug in a again. Okay, negative 8 squared would be 64, minus 4, that would be 60. And that's a pretty good start, but we do need to reduce our radicals. So 60 is like 2 times 30, 30 is 2 times 15, 15 is 3 times 5. So instead of saying the square root of 60, we can say 2 square root of 15. There's a 3 and a 5 left behind. And then finally, because this, and this all evenly divide by 2, we should do that. And so then there would be our 2 zeros. Okay, so since question 1 is a quadratic, its biggest exponent is a 2. That's why I'm using the quadratic formula. Okay, any questions about that one? That familiar enough? Done that recently enough? Now again, I'm not going to take the time to graph this, but if I graphed it, I can tell that it's not going through the x-axis at nice whole numbers. They're going to be some weird decimal. So that weird decimal is usually not helpful in higher math. This would be the exact value. So if you change this to a decimal and you change this to a decimal, it should be the same decimal that hits the x-intercepts. So technically, quadratics are polynomials, but they're pretty basic polynomials. The polynomials that we really speak on when we say polynomials are things that have a degree higher than 2, like a degree of 4, degree of 4, degree of 4, degree of 3. Things higher than an exponent of 2 is typically what we mean by when we talk about polynomials. Okay, so if I want to know the zeros of this, again, 0 means where does it equal 0? So set 0 in place of y. Now, you can throw these numbers in quadratic formula if you want to, but they're not going to work. This is not a quadratic. Quadratic formula doesn't help you here. So, our backup plan is to factor. So, if you can factor a quadratic, if sometimes that's a viable option, then higher degree polynomials we can also factor. So this guy is the difference of 2 squares. So if you recognize that pattern, it makes it a little bit easier to factor. I'm not going to do this, but just so you know, If you don't want to memorize the difference of two squares pattern, even though I think that is so convenient that it's worth it, you could always just squeeze in a 0 x's in the middle, and then you could work it like a trinomial. It has no x's, so that's the same thing. Okay, and then if you wanted to factor further, although I guess you don't have to here, this is also the difference of two squares. So where this guy equals 0 would be as 0, because if I could make this be 0, I don't care what those are. 0 times anything is 0. If I could make this be 0, the whole thing would be equal to 0. So it looks like plus or minus 2 is 2 of our zeros. Then to find this one, this is the sum of two squares, so this doesn't factor more, but we can just set it equal to 0 and solve. Subtract over the 4, take the square root of both sides. You have to remember that when you take the square root, you need plus or minus. The square root of 4 would be 2, but the square root of negative 4 would be 2i. Remember, the negative comes out as an I. Okay, so one thing to help you know if you've answered all of this correctly, or not correctly, but if you have all the answers, that there should be 4 answers to this question, is actually the fundamental theorem of calculus. Sorry, fundamental theorem of algebra. The fundamental theorem of algebra just says whatever the degree is how many zeros it has. If it's a 4th degree, it has 2 zeros. If it's a 2nd degree, it has 2 zeros. So as soon as we see 4th degree, we should know that we have 4 answers to that. So factor more, set each factor equal to 0, and that's one way to find some of the answers. Okay, so let's see if that works on question 3. This is a trinomial, so the A times C method still works. The product sum method doesn't only work for quadratics, but I'm going to try to get it with guess and check. X squared times x squared is x to the 4th. Multiply to negative 48, but then maybe add up to 2. We can do like a plus 8 and a minus 6. That makes the outer part of FOIL negative 48. And if you compare the outer part of FOIL, I'm sorry, the last part of FOIL is negative 48. If you compare the outer part of FOIL with the inner part of FOIL, those combine to be plus 2x squared. So again, I'm using guess and check there on the test. If you couldn't figure it out with guess and check, just make sure that you can do product sum or some other method. It's really the only realistic one. Now, these don't factor further, but that's okay because I can still set this equal to 0 and solve. I'm not going to need quadratic formula for that. And I can set this one equal to 0 and solve. Over here, we can subtract 8 and take the square root of both sides. Square root of both sides is plus or minus. Over here, we can add 6, take the square root of both sides. Again, square root of both sides is plus or minus. So this one looks finished. Positive square root of 6, negative square root of 6. This one we need to reduce. The I can come out. The negative comes out as an I. And 8 is 2 times 2 times 2. So instead of saying square root of 8, you should say 2 square roots of 2. Okay, so again, 4th degree. So you should know that you're not finished until you have 4 zeros. Some of them are real zeros. Real zeros show up as x-intercepts. Some of them are imaginary zeros. Imaginary zeros don't show up on the graph. But that's how you would find those. Okay, so let me give you a second to catch up there and make sure you guys are okay with that. Okay. Is this familiar? You guys remember doing this last year? Okay. I really think the hardest step of these is the factoring. You just have to be extra careful with factoring. Sometimes you have to simplify radicals, but luckily we've reviewed that recently. Dealing with a negative under the square root, making it an I, but we dealt with that recently too, so I don't think that should be too hard for you. Okay, so then let's look at it from another angle. This is a 4th degree, so this guy should have 4 zeros. So maybe one of these is like plus or minus, maybe that's why they made 3 blanks. But they tell us, oh, because they want us to find the remaining one. They tell us this one, and somehow knowing that one, we are supposed to know what the other 3 are without a calculator. So this is definitely one of the more involved questions. The first one should be a gimme, because imaginary zeros, anything with an I in it, always come in conjugate pairs. Check it. Remember, conjugate just means you switch that middle sign. So if 2 plus I is a 0, you have to know this one's super important, because if you don't know this one, then you're stuck at the beginning. We're going to need it to help us find the other ones. Imaginary zeros always come in conjugate pairs. So notice, I didn't point that out to you in the last 2 questions, but it was true. If 0 plus 2i squared of 2 is a 0, then 0 minus 2i. Like, you can put the 0 out front if you want to, but they're conjugates. Middle sign is different. If 0 plus 2i is a 0, then 0 minus 2i is a 0. Imaginary zeros always come in conjugate pairs. So you didn't have to know that for question 2 and 3, but you have to know it for question 4. Okay, now if we go backwards, so like right here, if we have the factors, we set the factors equal to 0 and solve, and we get zeros. But what if we have zeros and we want to go the other direction and write them as factors? Well, to change a 0 into a factor, you just have to do x minus. X minus the 0, and then x minus the 0. Minus a negative becomes a plus. So let's do that for these two. If this is a 0, x minus all of this, distribute your minus, and x minus this, distribute your negative 2. So x minus the 0, distribute the minus, changes your zeros into factors. Well, let's go ahead and multiply this together so this looks a little more familiar. So if I take 3 things times 3 things, I'm going to get 9 things. But x times all 3 of these would look like that. If I did negative 2 times all 3 of these, you get those 3 terms. And then negative I times all 3 of these. Minus I squared. Okay, so every one of these things has to get multiplied by every one of those things. 3 times 3 gives you 9 things. So at first you might think, well, how is this supposed to be helpful? Well, notice a lot of this stuff cancels out. We've got a plus 2i minus 2i. Those go to 0. We've got a plus xi minus xi. Those go to 0. We've got an x squared that has nothing to combine with. We have minus 2x minus 2x. So those could be minus 4x. And then we have a plus 4 and a minus I squared. So do you guys remember what I squared is? Okay, so if we didn't review that yet this year, but we did talk about I is the square root of -1. So I squared is just -1. It's like you're squaring both sides. So this minus a -1 is really like a +1. So another way to say this mess times this mess is to say x squared minus 4x plus 5. This is much more familiar. This looks more like what we've done. How that's going to be helpful to you is if I divide this out, it's like removing these zeros away from this polynomial, and it's going to help me discover the last two a little bit better. And the only way I can divide this out, you can use synthetic division when it works, but synthetic division doesn't work for this. So we have to do this. We're trying to divide out the two zeros that we know about. But because these came from zeros that were given to us, we absolutely know that the remainder is supposed to be 0. So if we don't get a remainder of 0, we know something went wrong in our arithmetic. So from the long division process, x squared times x squared is x to the 4th. X squared times -4 would be -4x cubed. And x squared times 5 would be 5x squared. Change the signs and add. Those go to 0, those go to 0. We get that. Do our algorithm again. -6 times x squared gives me -6x squared. Oh, I didn't. Yeah. Right here. See, and the reason why, so, of course, the longer the long division question is, the easier it is to make mistakes. But as I said, these have to divide into it evenly because these factors came from zeros, and zeros always divide into it evenly. So I messed my arithmetic up right here. 1 minus 5 would be -4. So that should have been that. Okay, and then this would be 16x. This would be -20. And when we change the signs and add 0, 0, 0, that divides into it perfectly, which was completely expected. So unlike other long division, this one you have a check. You know if you're doing it correctly because it has to divide into it evenly. Okay, so why did I do all that? How does that help me find the last two? Okay, you don't remember this part? So I basically divided out these zeros. You have to turn them into factors to divide them out. But this leftover, carry that down over here. Once I divide those out, what's left over is x squared minus 4. Oh my gosh. Okay, and so the other two zeros have to come from what's the remaining factor. So if we set this equal to 0 and solve, we would get 2 and -2. So it's pretty easy to see the last two once you divide out those factors. But to divide out those factors, you have to long divide this out, usually. Sometimes you can do synthetic division. To even get this factor divide out, you have to change your factor or your zeros into factors, multiply them together so you even know what to divide into. So that should be your hardest question there. But it's very important that you can do those skills. And it's important that you see how those things interact. Now, if this was a calculator question, again, I don't think we plan on giving you a calculator on the test, but that has changed recently. So, if the question just said, use your given 0 of 2 plus I to find the others, and you had a calculator, so like especially the ACT, if you graph it, that's usually the fastest way. Again, you don't always have a calculator though. Okay, so now I can see, hey, it looks like he hits at 2. Trace 2, enter, confirms 2, 0 is a point. And he looks like he hits at -2. -2, 0 is a point. So if I had a calculator, I would personally just graph, go straight to the x-intercepts, and I would have those two almost instantly. The only way you would ever get this one, even with the calculator though, is to know that imaginary zeros come in conjugate pairs. If we tell you 2 plus I is 1, it is expected that you know 2 minus 1, or 2 minus I. If 2 plus I is 1, then 2 minus I is 1. Okay, so you probably need to revisit that question, but is there any immediate questions you have on it I can help with? Okay, then question 5 is kind of the same idea, but it's going to not be as messy. If x plus 4 is a factor, then that guarantees -4 is a 0, because that's where it equals 0. Now the other two, if I had a calculator, I would graph, and I'd hope I'd see them on the x-intercept, or the x-axis. And I'd hope that they were nice whole numbers. If that's not the case, then we have to do a similar process to the last question. You can either divide out this. I'm not going to do it this time for some variety, but you can divide out this, and you're going to get so many x squared something something something, and then you can either solve that by factoring or just setting it equal to 0, and you can get your other two. So dividing out the factor that you know about to reveal the hidden factors to get to hidden zeros. But because this one is just x plus a number or x minus a number, if you would rather, you are welcome to do synthetic division. If you're not sure that you know the process for one or the other, then my suggestion would be to do both. But so this number is not 4, it's a number where the divisor equals 0. And because I know this is a factor, by definition that means it divides into it evenly. So if I don't get a remainder of 0, I'm going to catch that something was off. So add down, multiply, add down, multiply, add down, multiply, add down, and confirm that 0 is a remainder. Yes?
If you did long division, can you get like a remainder?
You should still get a remainder of 0. Should divide into it evenly. Yeah, whether you do long division or synthetic division, you should get 6x squared minus 7x minus 5 as your quotient. That's what's left over. Now, I'm hoping I don't have to use quadratic formula here, but even if I do, at least I know I'm near the end of this question. As long as I can always get it down to a quadratic, we always have that tool of quadratic formula to finish solving it. So personally, I'm going to try factoring, and I honestly don't know, but let's see, this would be minus 10 plus 3. Yep. And I guess if you struggle with factoring, you can do quadratic formula, but if you struggle with factoring that much, for your sake, you probably just want to practice factoring more. You don't want to do quadratic formula all the time. So now that I can see the leftover factors, I can set them equal to 0 and solve, and I can find those two hidden zeros. So this kind of has the same idea as the last question, it's just the last question was messier because I had to take an imaginary 0, I had to know that its conjugate also existed, I had to change them to factors, I had to multiply those factors together to get a quadratic, I had to divide it out, just like I divided this out, but because it was a quadratic, I had to do long division. After we divided it out, we were left with a quadratic, and from the quadratic, we got the other two. It's like this. When we got it down to quadratic, we got the other two. Okay. And our next to last one, find a third degree polynomial, so biggest exponent is a 3, that has real coefficients and with zeros at 1 and 6 minus I. So this is kind of a backwards question. Instead of saying here's the polynomial function, find the zeros, we're saying here's the zeros, figure out what the function would be. So if this is a 0, x minus this is a factor. Bless you. 0 factor. If I do x minus this one and distribute the minus, I change this guy into a factor. Now if I multiply this mess together, it's only going to be a quadratic because I only have two zeros. Quadratic isn't degree 3, the quadratic's degree 2. So what am I missing here? So the other understood one is 6 plus I. That's super important because if you don't know that, then you don't have much chance of moving on. So x minus this, distribute your negative. And then this should be the one that gives us what we want. But when it says real coefficients, like these are factors. We don't have any coefficients yet. So we have to multiply this mess together. I would recommend multiplying these together first. So x times all 3 negative 6 times all 3 and I times all 3. We saw this a minute ago, that it starts to look almost impossible. It gets really, really messy. But most of this is going to cancel out. Plus xi minus xi would go to 0. I have this x squared, minus 6x would be minus 12x. 6i minus 6i, those cancel out and go to 0. And then what about these two? 36 and minus I squared. Do those combine? Just make sure that you remember I squared is negative 1. So this is minus negative 1. So that's like a plus 1. Plus 37. So those combine even though they don't look like it at first glance. So the reason why I suggest you multiply those two together first is because all the I stuff should go away. Okay, now we need to multiply on our x minus 1. So x gets multiplied to all 3 of these. That would give us 3 terms. And negative 1 gets multiplied to all 3 of these. Looks like we're about ready for our answer here. Is this how many x cubes we have? That's good, 3rd degree. combine our x squareds. Combine our x's. And we have this as a constant that had nothing to compare with. Okay, so as a check, what should we know about this graph if I graphed it in a calculator? Do we know anything about what this should look like? Yeah.
Should have a y-intercept at -37.
I don't know about y-intercept. At -37?
Yeah, because whenever you said it equal to 0, that's the only.
Okay, that's true. Y-intercept of -37. Plug in 0 for x, you get -37. But I was thinking more of this stuff. If they told us they were supposed to be a 0 at 1, what does that mean about this graph?
That's the x-intercept of 1.
Okay, and if these are our other zeros, what does that tell us about the graph? Right, these don't show up as x-intercepts. So when I graph this, that's kind of a check here because, you know, obviously we can all multiply this stuff, but when you multiply that many things, it is definitely possible to make a multiplication mistake. It better be the only x-intercept because it's the only 0. So I did all that work and I don't trust myself enough here, so take the extra minute. So that should be minus plus 49x. Okay, so the fact that it only has one real 0 means it better only have one x-intercept, and our real 0 was 1, so your x-intercept better be 1 as well. So if I had mismultiplied something, if I missed a sign, then this would not be true. That would not be consistent with what it was supposed to be. So I guess that doesn't 100% check it, but very likely that the rest of it is okay. So this is like the third time now we've talked about how to change zeros into factors. So make sure you know that one as well. Okay, any questions about 6 while it's up? Sorry, I need to update attendance. It's too slow. Okay, so one more. Write this as the product of 4 linear factors. Okay, so in other words, find the factors. I'll remind you what linear factors are at the end. So, why don't we try to factor it? Factoring works for more than just quadratics. X squared times x squared gives me x to the 4th. Minus 6 times positive 1 gives me negative 6. And if I FOIL this, the outer combined with the inner would be minus 5x squared. So that's looks like how that factors. Then I could set this, this doesn't factor down anymore because this is not a perfect square. But that doesn't mean I can't set him equal to 0 and solve. Don't forget plus or minus. This is a 4th degree, so we should have 4 zeros and 4 factors. So looks like one 0 is square root of 6, another is negative square root of 6. If you forget the negative, you should catch it before you're done. We could set this one equal to 0 and solve. Subtract the 1, take the square root. If you take the square root of both sides, it's plus or minus. And then what's the square root of negative 1? Okay, so it looks like I and negative I are my other zeros. So let's change them into factors. X minus a 0 is a factor. X minus a 0, but we don't say minus a negative. X minus the 0, X minus that 0. Okay, and then this is what they're looking for. So what do you think they mean by linear factors? What does linear mean? Okay, linear is the thing that you did in Algebra 1. It's when your biggest exponent is 1. So like, technically, right here, this is a product of factors. This is a factor and this is a factor, but these aren't linear factors because the biggest exponent is not a 1. Those are quadratic factors. These are linear factors because the biggest exponent is a 1. So don't let those directions throw you off there. Okay, so let me do just a quick review here and give you a chance to speak up, and then I'll remind you of the optional bookwork I'm going to post. Okay, so all the way back on question 1, we reviewed quadratic formula, kind of to emphasize as long as you can get something down to quadratic, doesn't matter how messy it is, we have a tool to deal with that. But typically when we say polynomials, we mean things of exponents bigger than 2, degrees bigger than 2. So for question 2 and 3, I factored both of those, said each factor equal to 0, and I found the zeros. Degree 4 means 4 zeros, degree 4 means 4 zeros. Question 4 was the hardest one because we had to know that imaginary zeros come in conjugate pairs. So it's like they gave us 2. If we changed them to factors, multiply them together, then we got a nice looking quadratic, and we could long divide out the quadratic to see the remaining factor was x squared minus 4. And once we have that written that way, then we can set that equal to 0 and solve to find the remaining zeros. So definitely the longest question. Number 5 was kind of the same idea, but I just divided out x plus 4 by doing synthetic division of negative 4. And because I'm told it's a factor, that guarantee that it should have a remainder of 0. But you can do long division if you want, but you should still get a remainder of 0. But the whole purpose of that, again, don't just memorize the steps. That's not going to help you pass the test. The whole purpose is to take this third degree and get it down to a second degree. Because second degrees, even if it didn't factor, which I hope it does factor, we could have at least used the quadratic formula if nothing else. So we had the 1 0 that was given to us, and then the other 2 came from the quadratic. But to expose the quadratic, you have to divide out the zeros and the factors that you have. Okay, go on the other direction in question 6. If we took this 0 that was given to us and changed it to a factor, take this 0, change it to a factor, and then understand that this one has to be a 0 as well and change it to a factor, multiply that big mess of stuff together carefully, and we end up with our third degree. Biggest exponent is a 3. We had some kind of a check by graphing. Real zeros show up as x-intercepts, imaginary zeros don't. So we saw that when we graphed it, which means this messy arithmetic was all probably fine. And then number 7, same idea, slightly different directions, but factor this to get it down to quadratics, solve this quadratic to find 2 zeros, solve this quadratic to find 2 zeros, and when you have zeros, x minus each of those give you the factors. So getting these to an exponent of 1 is what makes them linear factors. Okay, so all of that should be reviewed for you guys from last year, but again, it's probably been over a year since you've done some of that. But is there anything that jumps out at you that you know you need to ask about? How many of these do you feel like you could have done today without me doing this at all? None of them?
Be like
Okay, yeah, hopefully number 1, right? Okay, so again, I will, next class on the review, I'll squeeze some of these questions on there to help you prepare, but really this is going to be important for you on your test. This will only be 30 to 40% of your last test. The majority of your test is still the rational function stuff that we spent multiple days on, but the questions that we ask will be very similar to these question types. So you need to make sure that you can do these processes and that you understand why you do the steps that you need to do for these. So I am going to, on my website, post the optional bookwork. So if there's a question type or 2 on this worksheet that you feel like you need to practice more before you would be ready to do it on a test, then I encourage you to do that.